Hello everyone. In this video, we will learn how to build a custom name entity recognition model. First, we will look at how to use Spacy for name entity recognition, and then we will look at how can we build model for our own entities. For example, default Spacy model comes with an entity recognition model which is capable of identifying a generic entities like if there is a name of the person, organization, places, etc. And what if we are dealing with, let's say, medical text data and we want to identify the name of the medicine, medical condition from that text data? Then we can build a custom name entity recognition model using Spacy. This video is inspired by this blog post, which talk about the same thing like custom name entity recognition. So first thing, let's import the Spacy model. If you go to Spacy website and look at the models, you will find the Spacy models for each language. You can go to the English language and you can see for English we have 4 models. Here is the small model, medium, large, and there is a TRF which is transformer model. And we will be using the large model here. Models are like small, medium, large as per their size and their capabilities. The large model is more accurate than the small models, and you can see what components we have for that particular model. And one of the component we are interested is the NER component, that is the name entity recognition. And here you can see how to download that particular model. So let's go back to Colab notebook. We have imported Spacy, and then we can use Spacy download command to download this particular model that we are interested. It might take some time, like maybe 40 seconds to 1 minute. So seems to be it is 400 MB model. And once we download the model, we can use the spacy.load method and specify the name of the model that just we downloaded, and the model will be loaded in this variable. We normally call it NLP variable. Currently it has downloaded, now it is installing. Okay, it has installed successfully. Now we can see we can load that model using the spacy.load method. It's loading. Meanwhile, I will just clear this output. Yeah, now it is loaded in this NLP variable, and we can see it is of a type Spacy language English instance. Once we have a Spacy language model, we can pass any document or a text into it, and it will create the document object. So let's run this statement, and we can see it is a type of the doc. First, we will see what is inside the doc. So doc object looks same what we have passed, similar to the text, but it has a different properties now because it is processed by the Spacy language model. And we can also check the type of the doc variable. So type of the doc variable is a type doc. So Spacy has a specific variable called a doc, and this doc object has a property called entities or entities, and this is where all the extracted entities, the name entities, we can find out. So if I click, we can see from the about text it has find out two entities, Donald Trump and USA. And we can first of all see even the entity is of some type specific. Each entity in these entities is of specific type. We can also see doc.entities will be the list of entity, and each entity has some type. Let's visualize what is the type of this each entity. Okay, so here is the entity Donald Trump, and we can see this is a specific type of the Spacy object called a span object. Now this information is important, that how did we pass information, let's say text, to the NLP object, and then we got a type of doc object of type doc, and then doc stores all the entities inside this entities variable, and each entity in this entire and each entity inside this entities variable is of type span. because when we're going to train Spacy model for a custom name entity recognition, we have to create our training data in the same format. We have to take each training example like this, create a doc object, and then add entities available in our training example as a list of span object. And then once we train the Spacy will be able to predict the same way custom entities, just like it is able to predict the Donald Trump and the USA as an entity. And Spacy has some visualization module where we can visualize the entities it has predicted. So we use displacy, and it has a rendered method which take the doc objects processed by the Spacy module, and then we have to use style, and we are want to visualize entities, and since we are in the collab notebook, we call Jupyter as a true, and then it will visualize. Now we can see it has identified Donald Trump as a type of person and USA as a GPE. Here GP is geopolitical entity. So it is able to identify specific or generic entities like person, place, organization. But our goal is to build Spacy model which will identify entities of our interest. So we have some medical data. I took this data from the Kaggle, and we want to use this medical NER data which is already tagged for the medical entities. So let's go to there. Yeah, so we do have this, data which has some type of entities, like it has some medical condition, it has some medicine name, pathogens, and we want to identify those entities. So let's go back to our and load that data. So I have already downloaded that particular data set, which is the medical NER, medical name entity recognition. Let's load that data set, and the data set gets loaded into the data example. So here is what all examples we have, training examples. We can look at the first training example. Okay, seems to be there is a lot of things, but we can see each training example is actually one dictionary. So we can look at what are the keys of that dictionary first. So let's look at what are the keys of the dictionary. So the dictionary has content, annotations, metadata, and classification. We are interested in content and annotation. So let's look at, for a first example, what does content field has. So content is nothing but some medical text. And then for the same example, we can also see the annotations field, which will be having all the entities found in this text. And we can see it has many entities. The first example that we are checking has a multiple entities because we have a list of entities. So let's look at any particular entity and see what all field that entity annotation has. So the Kaggle data contains this annotated information for each entity present in each example. And we can look at, we have example ID, we also have the human annotator who has annotated this thing, but we are interested in what is the tag name, which is the type of the name entity. So this particular entity is of type medicine, and where does it is located? We can see it's a start index in this text and the end index in this text. So the entity medicine of a type medicine is located at the 360 index in this text, and which is ending at 371. So whatever between 360 and 371 is of type medicine, and actually that text is this particular value. Okay, so we saw what is there, but we are only interested in three things. We are interested in this type, which is the tag name, where does it start and where does it end. So let's take these few things of our interest. So we will create a new variable or the list of training data here. We will iterate through our data examples, what we just loaded from the Kaggle. And then from each example, we will take the content field, that is where the text is located. And then we will also take the entities field. To get that entities field, each example has the annotation. That's what we look at here. So we will iterate through those annotations, and we will only take annotation start, end, and the tag name as we discussed. And then For each example, we are putting all that information in a temporary dictionary, and then eventually we are appending that dictionary to our training data. So our training data is nothing but the list of dictionaries where each dictionary is holding our one example, and we can look at what is the first example we got after preprocess. So our example has a text field, and then it has entities field, and entities is again a list of entities in that text, and each entity you can see we have three things: a tuple here, the starting index, ending index, and the type of the entities what we have inside that particular text. We can see it better way here. What is the text, what is the entities here? Yeah, we can see we have many entities, and we can see the first entity is located between 360 and 371. We can also see what is the value of that particular entity. So let's take the first example text field and just see, since it is a string, we can index it using, we can see what from 360 to 371 what is located. Yeah, so this is the value located inside this string at the index 360 to 371, which is of type medicine. And that's what we want to teach our Spacey model, that how does the medicine type look like. And similarly, we have medical condition and the other types also. To train a Spacey model, Spacey required training data to be in a particular format. Spacey advised the training data should be of a type docbean and which will be saved as a .spacey format. And do you remember earlier when I talk about how does Spacey does prediction on NER data? When we pass the text, it has a doc object, and the doc object has the entities field, and then each entity is nothing but actually a span object. And we have to do the same thing. We have to convert our training data in the document entities and the span object. So let's go back here. So the first thing, we will import the docbean object. This is the object where we're going to append our all documents that we're going to create. And we will use the blank Spacey model here. And then we will also use some utility. A filter span utility comes, we will see what it is. Now let's iterate through our training data, what we have currently. And for each example, we took our text field, and then we take our all entities and we call them as the labels. As I mentioned, we have to create the document object for each example. So using the NLP language object, it has a method make doc, which will take our text field for that particular example. Now we got a doc object. Now we want to append entities to this doc object. So first we will collect our entities available inside this label filter. So we'll iterate through our labels, and we know each of our entity label or entity annotation has three things: start, end, and the type of the entities, right? So this is where we're going to create for each entity a span object. We can create using the method doc.character span. We can create that span object giving these three information: starting, ending, and the label. And once we have a span object, we check some sanity check whether the span is none. If it is none, we will skip that particular annotation. And if it is a valid span, we're going to append in our list of entities. And once we have all the entities for that example, training example, we will pass those entities to the filter span. So filter span makes sure we don't have any duplicate entities, and it checks for other sanity checks. And once we get those filtered entities, we want to put it as a part of doc.entities variable, and we will simply put those entities inside this doc.entities. And this is where we created our first document using our first example, and then we will append that document to the docbean object that we created on the top. And once we process all such examples, we will have a docbean object, which is nothing but the list of document that we created, and we will save it to the disk. So let's run this cell. Okay, it also skips some of the entities, and it should now, if I refresh here, we can see the train.spacey file come. Now we have a data which is required by the Spacey format. Next thing, before we start Spacey model training, Spacey required a config file. And if you go to this URL where Spacey explains, or Spacey helps you to create that config file. Okay, if I go to this quick start URL, here is the UI to create your config file. So it suggests which language we want to build. So we want to use the English language, and what components we are interested. We are interested in the NER, the name entity recognition here. Whether we want to run it on GPU or CPU. Currently we are interested on CPU. Then we have choice whether we want efficiency or accuracy. Efficiency, the models will be the smaller, accurate model will be the faster. Sorry, the accurate model will be the larger but slower inference, but we will go with the accuracy. And then as you select, the config file gets updated. So once you select what we want, we can copy that config file, and we can see we can store it as a base config.cfg. So let's take that and clear one. Let's create one file here called base config.cfg, and we will paste what we copied, right? Once we created that base config, we have to run Spacy init fill config. So we have to fill the base config, and then it will generate the final config file. So it takes our base config as per our priorities, and then it also fills some default values, and finally we get the config which contains our selected configuration and also the default configuration, right? So let's fill this particular base config file. So we'll run that command init fill config, and it will take our base config and convert into the new config file. Yes, it got saved at config.cfg. We can see that file, yeah, and we can look at it. It has a lot of different, it has our model name, the large model name, and some of the interesting thing it has is this, like what is the batch size for training. Instead of 1000 we will keep it 100. And another thing I want to modify is the training properties. If I go down, there is something called training, which states the maximum epochs for the training. And if it is by default it is 0, it will try to optimize as much as possible, but we will only train for the 10 epochs. Let's save this file. Okay, now we have a config file, the final config file, and we can see when we created the final config file, we also got the next command, that how to train now file. So we have a Spacey train command which takes our config file, and then we have to give the training file path and the dev or the validation path. So we have that command here. For the training path, we give the train.spacey, what we created. And since we don't have any validation or the development set, we simply give the same set as the train spacey. Now let's run this command. It might take 3 to 5 minutes to train a Spacey model. We can see some of the details. Since we are running on CPU, that's what we selected during the configuration, and it shows what pipeline it is initializing. It is using two pipeline, token to vector and the NER, and those vectors are coming from this model. And here we can see the progress, the epochs, and we could see the loss for those both the pipeline component what we have, and then we have ep score, precision, recall, and the overall score. Okay, seems to be model training has finished, because we can see here progress, and model has, we can see it has saved in the output directory. If I refresh here, we could see we have a model based, and the model last folder got created inside the current directory wherever we are running the Colab. We can load the model based folder. For that we have to give spacey.load, and where is our model located. We can give the model based folder path, and it will load our new model. Let's call that model as a NLP NER model. Once we have that model, we can pass same way the text what we earlier pass. We are passing this medical text into it, and then this time what we will do, we will also pass options, some color options to our visualization. So we can pass our entity type. If it is pathogen, we want to use this color. If it is medicine, we want to use this color, and we can pass this color as options. So let's run the displacy function again with the rendered method and pass our document, which is processed by our custom name entity recognition model. And we can see it is able to predict certain words as a custom type. Now it is saying that this particular word is of type medicine, this thing is a medical condition. This way we can train a custom name entity recognition model. Now we took the use case of the medical data where our entities were medicine or a medical condition. In your case it could be different. Your domain could be finance or it could be retail domain, and you have your own entities that you need to extract. The main important thing is creating the training data in that particular format what Spacey expects, and you also need to annotate your data such that you know what is the type of your entity and where is the start and end of that particular entity. I hope you find this video useful, and if you haven't subscribed to channel, please do subscribe. I will be creating similar natural language processing video including libraries like Spacy, Hugging Face Transformer and GPT-3.